This begins E555 with Dr. Zahid, February 13, 2014.
Thank you very much. Good morning, everybody. Let's review quickly the scheduling that we started talking about last time. We started looking at GPS. So this is the GPS, which is called the generalized processor sharing, and its approximation, which is called the FQ. FQ stands for the what? Pair Q. Let me give you also an example that I already gave the afternoon session, but we ran out of time in the morning session, so I need to make sure that you understood it. Let's review it quickly before I give you the example. Okay, can you zoom back please a little bit? Thank you. Thank you. In the generalized processor sharing, every flow, you have their own what? Their own buffer. Every flow, they have their own buffer, which means what? You are isolating the buffers, isolating the flows, and the server will get what? An infinitesimal amount of what? Data, even below 1 bit, an infinitesimal amount of data from each one of them, which means what? They are all look or seen be served simultaneously. I remember there is no waiting in here. There is no waiting in here. They are going to be simultaneously. Okay. And this protocol, this mechanism, scheduling mechanism, will lead to the max-min fairness algorithm that we talked about earlier. Okay, so in this case here, let's assume, for example, the capacity was C. Let's assume the capacity was C. Here, I showed you this last example. Let's assume here is C. This is the capacity of the server. Okay, and let's assume they have 2 packets here arrived, each long, 1 unit long. In the case of the what? In the case of the GPS, they are going to be served simultaneously. They are going to be served simultaneously. And both of them are going to finish at what time? They are going to finish because in every round, every one of them will get what? Half the capacity. Half the capacity. So this one is 1 unit, 1 unit, 1 unit, and the capacity is 1 unit. In every round, they get what? 1/2 unit. It means both of them will finish at what? At 2. Clear? Both of them will finish at 2. Whereas in the packet by packet pair queuing, what will happen? What will happen is that one packet will be served, and then what? Finish, the other one will be served. Which means what? It means when this one starts, when will this one finish? In packet, when will this one be finished? This one will be finished at 1 because the entire capacity is allocated to it. This one is, and then what? It will start service at 1 and at 2. You see, by the way, both of them, in both scheduling mechanisms, both of them ended at t equal to what? 2. Ended at t equal to 2. But they are not identical. They are not identical. Did you get? Okay, good. Now, before we get back to the charts, let's review what we have here. What we have here is that in pair queuing, the scheduler will calculate. Thank you, will calculate a finishing number, again, I call it a finishing number. Is that a real time? It is not a real time. It's just a tag. Clear? It's just a tag. that indicates the order finishing service if GPS was used. And then start service, it means what? The pair queuing. Start service beginning with the packet of shortest or smallest finishing number. Clear so far? Clear? Okay, I want to explain to you one thing before I give you the numeric. I want you to see this. Look at this. Okay, this is in the what? This is in the GPS pair queuing. In the GPS, if those packets arrived, listen to this. Did this packet and this in time? This one would have finished what? At this point. Why? Because it happens to be what? This one would finish at what? At this point. Are you following me or not? They came at the same time so far. Clear so far? Okay. In the pair queuing, when the packets come at the same time, the scheduler will calculate what time would they have finished. At what time would they have finished if what? If was used. He will determine that this one would have finished before this one. So what does he do? He first, and then what? This one. Are you following me or not? And then what, by the way? This one, and then this, that one. You notice all of them came at the same time? They came at the same time. Are you following me or not? Yes. They came at the same time, but when he scheduled them, he will schedule them what? This one first, this one second, this. Clear? Okay. Now, let me show you one more thing before I give you the example, so that you understand what I'm talking about. I want you to see this. These are what? Two flows. These are two flows. Tell this one and this one. I need you to understand it. Okay, in here, what do I have? A packet flow 1, F, which is the finishing tag, is equal to what? 5. What does 5 mean? Packet, if GPS was used, he would have finished at what? At 5. Clear? Would have finished at what? 8. This would have finished at what? 10. He will what? 5, followed by 8, followed. Did you get this or not? But I want you to understand what does this mean. Look what this means. In this case here, scheduler, the pair queuing scheduler, already started serving this one. See this one here? Did you get this or not? What is the finishing number of this guy? What is it? 10. Then arrived another flow, a packet, which would have finished at what? 2. Another one was GPS. Which one would have finished first? This one or this one? This one would have finished. Tell me or not. Tell me what happens. Tell me what happens. Which one first? This one. Why? Because he has already what? Started transmission. In other words, the scheduler is not going to what? Preempt. In this case here, did this one thing or not yet? Not yet. So he is going to serve what? Number 5 first, followed by what? 10. In here, this one, the scheduler has already started servicing this one. Packet came in a different flow with a what? A smaller finishing number. Clear? They cannot preempt this one in the pair queuing. And that, which means what? This one continue and this one is after. And that is, the pair queuing is only emulating, is not identical to the GPS. Because if that was in the GPS, which one would have finished earlier? This one would have finished earlier if that was the GPS. Clear? Okay. Now, let's get into the afternoon session. Let's see if you can follow it here in the morning session. Okay, how do we calculate? How do we calculate? The finishing tags or numbers. The equation I showed you last time is the following. F-I-K. Let's understand what this means. What is this? This is the finishing of packet can flow what? At what? At time t. He arrived at time t. This packet arrived, this is the case packet, arrived in I at time what? T. Clear? What is it equal to? The maximum. I'll explain this when you write it down for school. F I K minus 1 T R E. Okay. I'll explain again. I'll explain that to you in just a second. L I K T over what? I. Okay. Let's concentrate so that we understand this equation before I give you the example. This equation is for which one? Which one is this equation for? That's the GP or not. Once you start talking about round number and finishing numbers, we are talking about what? The GPS. But who is calculating it is the fair queuing scheduler. He is calculating these only to get what number so that he can start what? Serving the packets based on what? In the order of finishing numbers, starting from one which has the lowest and ending the one which is what? The highest. Clear? Concentrate here. A packet came in the GPS. In the GPS, a packet came at time K. So this is the flow. Let's assume that we do. Capacity is what? In C. Capacity in C. In GPS, what is the scheduler will do? In GPS, he will assign a what? He will guarantee that each one will get each active. Be the what? Number of active. Number of active flows means what? Those flows whose buffer have something in them. Those whose buffer has something in them. Clear? He is going to guarantee at least what? Each will get C over N share of the available capacity. Clear? Okay. Now, we defined the concept of a what? A round number. What does a round number means? Listen to what a round number means. Did we discuss this? Okay, let's see what it means. Let's assume one of them is what? One of them is active. All the others are what? Empty. This one will come an infinitesimal amount of data from this one. Yes? That is called a what? A round. Are you following on? Another flow comes in here. What will this one do? He will serve them, both of them, simultaneously, infinitesimal amount of data. When they both get service, what do we say? Another round is done. Is done. Now, this one came, another flow. He will serve all of them simultaneously. When he finish service, the same amount of service, to every one of them, we say what? A round has finished. So now, so the question is the following. Is the duration of the round the same? On what? Does it depend on which one is, how many flows are active? It depends on how many. The more flows that are active, the round will become what? Longer. Become longer because this one needs to what? Serve all of them. Are you following me on now? The round number have to be an integer. So for example, if I say the round number is what? Let's say 2.5. What does it mean? It means all active sources, all active got what? Equal amount of service for how many rounds? 2 rounds is in the middle of the what? Third round. Which means what? See, a round is finished. All active flows get the same amount of what? Service. So when we say R is equal, what does it mean? It means we are in the middle of which round? Third round. But the third round is not over yet. There are active flows that did not get service yet. Once the round number reaches an, what does that imply? It implies all the active flows got their opportunity to be. Did you get this or not? Yes or no so far? Okay, good. Now, it's always going to be what? Increasing. So dr of t dt, what is this? This is the slope is equal to what? C over what? N. What does that mean? C over more active what? The more active flows there, the slower is the increase of what? R of t. Keep in mind, R of t will not go down. Do you understand? What we are changing is the rate of increase. So what does this R of t look like? As I was showing in the example, R of t will look like a what? A piecewise linear. Clear, the slope will keep changing based on what? Based on the number of system. Clear so far? Yes? No. Keep in mind one more time. What are we doing this calculation? Where is this? This is in the GPS. Do you understand that or not? But who is doing the calculation? The fair doing the calculation because he is trying to figure out what? These packets that just the fair queuing scheduler, when would they have finished? If what? If GPS was, and based on that order, the fair queuing scheduler will decide what? Will serve them. Did you get my point so far? Okay, now let's see if you help me. A packet came in here, again in the GPS. He found the flow empty. Will he start service? He will start service right away. Remember in GPS, because everyone will get what? As soon as they are up, they will get what? Their share of service. Yes? Let's assume that packet, 2 units. Yes? And when he came, was what? 3. When will he be finished? He will finish at round number what? 5. You understand this so far? Yes or no? Why? Where did we get this? Now, when he came, the queue was what? Empty. Are you following that? Which means what? This is what? 0. This is K minus in the same flow, but the previous packet. Yes? That previous packet already exited. Are you following me or not? Okay. So what is the finishing number of this? The case packet is what? Is the current round number, yes, plus what? The length of the packet divided by the weight. Don't worry about the weight. We'll talk about the weight. Angelos will give you. Don't worry about the weight. Just concentrate on the L. The weights are all ones. Clear. So will he finish? He will finish at what? The current round number plus what? The length of that packet. Now, look at the second scenario. A packet K, I, packet, which packet? Packet K. There was another packet ahead of it in the queue. Yes? Answer me the following question. That packet that came at time, will he start service right away? He will not start service right away. Why? Because the serving what? The previous packet. Yes? So what does he need to, which one will be greater? This one is the what? Is the round number when the case packet arrived. What? This one was the round number. This one is the what? Is the finishing number of the packet that was ahead of it. Bigger, this one or this one? That one is bigger. You follow me or not? That one is bigger. So you take the maximum of them. Be finished. This case, the case one. He will be finished what? When this one is done, and then what? Additional what? Additional rounds to serve this guy. Did you get this or not? No. So what is the whole idea in here? The whole idea is that you need to keep track of what is when a packet what? When a packet arrived. Clear? The fair queuing will calculate this and he will determine what? What is the order of service of the act. Now, a couple of things I need to ask you before I give you the numerical example, which is the following. Do you see this number? Does it depend on the packets that will come after it? Will it depend on the what? On the finishing numbers of the packets that will come after? It will not. Do we agree with this or not? Yes or no? Does it depend? Does this one depend on that of the packet coming in a different flow? No, it doesn't. Are you following me or not? No, it doesn't. Clear? Okay, so each flow, this one only depends on what? The finishing numbers of the packet, not built after it. Clear? Okay. Did you get the idea? Okay, let's see if you can follow this example. Simply, this example I already gave it to the afternoon session. Let's see if you can help me. Example. I have 3 flows. This is the first flow, this is the second flow, and this is the third flow. And this is at t equal to what? 0. 1, you understand what 1 means? 1 means what? 1 unit length. This one is what? 2. This one is what? 2. This is C, flow B, and flow A. Clear? A question. One more time. Means, okay, these 3 packets, did they arrive at the same time? These 3 packets did the same time. They arrived at the same time, which is at t equal to what? 0. But they happen to be what? This one happens to be shorter than this one, shorter than this one. Shorter than these. Clear so far? Okay. Now, again, what are we doing here? GPS or fair queuing? GPS. To calculate the finishing number, then the fair queuing will what? Will just look at the order. This all, which one would finish, by the way, first in this case? So, of course, this one will be finished first. Now, listen to me before even I continue. Are they all going to get the same amount of service at the beginning? To be all getting the same amount of service. Keep that in mind. Okay. Another packet came of length 2 at 4. At what 4 means? 4 means what? At 4 seconds. At t equal to 4, another packet came of size what? Clear? And the question is telling you what? The finishing numbers of each of packets, sketch number, and in at what time the server is or become idle. Indicate at what time the server becomes what? Idle. Only when what? When all the packets get what? Get served. Clear? You can help me. What is F11? First of all, I'm sorry. A. What is FA1 means? It's the finish of what? Finishing number of packet 1 in flow what? A. What is the beginning? When he came. When did he come? At t equals 0. What was the round number? 0. What is the length of this guy? 1. What is the capacity? The capacity is 1 unit. Per what? Per second. 1 unit, he gets service right away. He will get service right away. Are you following up? He will get service right away. Now answer, when do you think this one will exit? At what time this one will exit? Will exit at t equal to what? 3. Why? Because every time he will only get what share? A share. 1/3 of a unit. And how long is he? He is 1 unit. Did you get this or not? So this one is what? 0 plus what? 1. And F B 0 plus what? 2. And F B C 1 is equal to what? 0 plus what? 2. And that's equal to what? That's equal to 1. That's equal to what? 2. That's equal to what? 2. That is so far. Yes? Now, can I calculate this or not yet? Let's see if you can I calculate this or not yet? This I cannot calculate. Why? Can you tell me what right now? I cannot calculate right now because what was the round number when this packet arrived? I know one thing for sure, is that when this packet arrived, the queue was what? Empty. Who's the first one has already what? Has already done. Did you understand what I? Yes or no? The first one is already done, but I don't know what is the round number when this packet came. He came at what time? At time equal to 4. I don't know what the round number is. Did you get this or not? Okay, so let's see if you can help me. This is T, what? R of t. Okay, at the beginning, remember R of t is going to increase in piecewise linear fashion. At the beginning, what is the slope? At the beginning, what is the slope? The slope is 1/3. Why? Why? Because all of them are what? One will get what? In other words, the round will take what? Will take to visit to what? To the first one, visit to the second one, visit to the what? Third one. Yes or no? So what? It's too, no, this is too long. I'm going to run out of space. What is the slope of this? So this is 0. This is what? T. And what is this? Can you tell? That's 3. And the slope of this guy is what? 1/3. Slope equals 1/3. And what is this? That's 1. Are you following me? I cannot hear you. Now listen to me carefully. Listen to me carefully. How much is this one get in 1 second? How much is this guy is getting? 1/3 of a service, 1/3 of a service, 1/3 of a service. 1/3 of a service, 1/3 of a service, 1/3 of a service. In the 3rd second, 1/3 of a service, 1/3 of a service. Answer me the following question. Are we done with this? When the finishing number, when the round number is the same as the finishing, that means what? That packet will what? Exit. Did you get this or not? Who exit here? Who? A packet. A1 exit. Why? Because it has reached its finishing number. Did you get this or not? Yes or no? Okay, now answer me the following question. At this point in time, are these done or not yet? Not yet. But what does the scheduler now give them? He will give, which scheduler? One more time, which scheduler? The GPS will he give them? He will give them half the share. In other words, each one will get what? C rather than what? C over 3. Did you get this or not? Yes or no? Which means what? Between 3 and 4. Why did I say between 3 and 4? Why did I say between 3 and 4? At 4, another packet will be coming here. Question. Will this packet, when he came at 4, when he be served immediately? He will be served immediately. This is the GPS. This is not the... Did you get this or not? This is the GPS. He will be served quickly. Okay. So now what do I have? Help me. I have... Did the slope change? Did the slope tell me what is this value? This is 5. And what is the slope of this guy? The slope of this guy is equal to what? 1/2. Did you understand why it is 1/2? Question. At this time, at 1.5, did these finish? These two, did they finish? Not yet. Why? Because we have not reached their what? Their finishing numbers. And that or not? Cannot hear you. Now, suddenly, at 4, what happens at 4? This guy came. Yes? When he came, what was the round number? When he came, what was the round number? 1.5. Now, can we go? Yes, we can. So what is it now? Equal to 1.5 plus what? Did you understand where this came from? Yeah, 1.5 is the what? Is the round number when he came. It is. 2 is equal to what? 3 point. Did you get it or not? Yes or no? Let me ask you a question. Assuming this one was not finished yet, was not finished when this one arrived. Yes? In other words, assuming that this FA1, it was, let's say, 5. Are you following me or not? Will this one be 3.5? 3.5, because then the maximum of these, the maximum of this one and this one will be this. You get this or not? But in this example, this one already what? Already finished. So he only needs number. Okay. Tell me now, will the slope change? Okay. Now, when will these, who is going to be served at 4? All of them. All of them. Remember, those were not done yet. When will they be done? When will they be done? At 2. Did you get this or not? So when this one reaches what? 2. By the way, did the slope change again? Did the slope change again? Okay, tell me, see if you can help. What is this? First of all, what is the slope of this guy? Agree? Okay. From here to here? From here to here, how much? Is 1/2. Yes? So what should this one? You lost me here. I think you lost me here. Did you lose me? What is this from here to here? 0.5. The slope of this guy. 1/3. Which means what? From here to here is what? 1.5. I have what? 1/2 divided by what? 3/2 is equal to what? 1/3. Yes or no? Cannot hear you. Okay. What is this? What is at 2? Both. B1. C1 exit. Are you following me or not? Exit. Clear? Yes or no? Okay. Now answer me the following one. Done? No, this one is not done. Why is it not done? Can you tell me why is it not done? When will this one, when we will be done? When this one reaches what? When the R of t reaches what? 3.5? Yes? Okay. Now tell me, what do I do next? What is the slope? The slope is 1 because that is the only packet left. So the entire capacity will be given to him. Now, he will be done. What is? When will he be done? Not sketch to scale, but you get the point. What is this? 3.5. What is this one? 7. Did you answer where the 7 came from? It's from here to here is how much? 1.5. And from here to here, how much? Well, this guy is what? Is 1. Yes? When will the server be idle? Server will be idle at t equal 7. Which server? When I say server, which server? The GPS, yes or no? Cannot hear you. The GPS server. Now tell me the pair queue. Tell me. Remember, in pair queuing is what? Packet per packet. We are not talking about what? Infinitesimal. So this is the time axis. Which one will start first? 0. He will choose what? He will choose the one that is what? Smallest fi. So he will start with what? A1. Done. When will be he done? Entire capacity is given to him at 1. Yes or no? What will he? By the way, in the GPS, 1. Number 1, packet number 1. When was he done? At 3. In here, when was he at 1? Did you get this or not? Okay. Answer me the next. What is the next one? The next one, there is a what? Tie. It's the B. Yes? When will he start service? 1. When will he be finished? Yes? Next. Next. C1. Yes? When will he start service? 3. By the way, in here, did they start service simultaneously? The GPS, did they start simultaneously? They started simultaneously. Are they simultaneous here? No. So when will 3? When will he be finished? Agree? The A2. When will he start? 5. When will he end? 7. Answer me the following question. Is the server going to be idle at the same time as the server will be idle at exactly the same time as this one? But are they identical? Not identical. This one is just what? Emulating this one. Are you following me? They are not identical. This one is just emulating this one. Did you get it? Yes or no? Cannot hear you. At round 1.7? Okay, when you speak, you need to look at me and you need to raise your voice. I cannot hear you. One more time. One flow.
Flow 2.
Flow 2.
At round 1.7.
At 7. You mean here?
Yeah.
He will wait because the packet ahead of it in what? In flow is not finished yet.
So will that change the finishing number of the second packet?
In flow 1? The finishing number of a flow 1? Why?
Yes, because the shear got capped. Because at that time, the packet in flow A goes to full shear, packet in another flow, then the slope's going to become...
Because this one came ahead of this one. This one came ahead of this one. In other words, if you are telling came, at what time this one came? The time, not the round number, but the time. Huh? T equal to what? T equal to what? 5. This one? Okay, at T equal to 5, somewhere in here. Yes? So what will happen? At T equal to 5. Now notice, by the way, at T ahead of it has not finished yet. Yes? So that arrival will not change the slope of this one. Is still a slope of what? 1/3. Yes? But this one will change. The slope of this. Why will the slope of this one change? Because between this one and this one, there will be what? 2 packets that are there.
So my question is, will that change the finishing time of the second packet?
Of which flow? You mean this one? You mean this one?
Yes.
This one is when he came. My dear, when he came, when this one came, at T equal to 4, the other one was... Did you get it? Did you get it? Yes? Okay, my dear, I cannot answer question types of what times.
Okay.
I can only answer the concept here. So you are telling me at time 6, the other one will tell me time 7. At T equal to what? 6? Ooh, which packet?
Number. For flow 1, flow A, packet 2.
He came at 6 instead of 4?
Yes. During this time, flow B and C have been finished, so there's no current flow between time T 1.5 and 1 before and the second.
My dear, I cannot do that. I cannot keep track. You are talking in real time. I cannot do that.
Okay. What
So-
I mean is, for the extreme case, when the first one, packet 2, is coming at time equal to 5,000, and during this time, flow B and flow...
Sorry, I lost the numbers. You are talking what? You are talking and giving me too many numbers and I cannot work in real time. Do you understand or
yes,
not?
yes.
That is what office hours are for. You need to come to the office hours.
Okay.
You are giving me, I'm not sure you are getting me too many times and I cannot what? I cannot digest it right away. Do you follow me on that? You are this time, this at this time, and by the time you get here, I forgot what you said at the beginning. Did you? All what I'm trying to tell you is the following, is that when a packet arrived, you need to figure out what is the round number when he arrived, and you need to figure out whether a packet ahead of it is still what? Is still in service or not. If there is a packet ahead of it still, then the term in here, the maximum of these two will be this guy.
Not do it, right?
If the flow is empty,
Yes. So empty. Like, we cannot draw a diagram.
my dear, concentrate, please. If the flow is empty, the server is what? Is idle. So what is the problem with this?
I mean, the wrong numbers.
The last round number
Idle.
was idle. You add to it. If the server is not If the server is idle, it will be incremented. It will just remain the same. You get my point or not? In other words, I want you to think about it this way. This will be what? Straight line. If it's idle. Is that your question?
Yes.
If the server is idle, then the slope will be equal to what? It's not going to change. Are you following me or not? Yes?
So if the servers are always run their own game, we keep the whatever left for last.
Okay, you need to see me in the office. I cannot spend that much time in here. I'm sorry. You need to see me in my office during office hours. You are bombarding me with, and I cannot what? I cannot keep track of what's going on. Claire, you need to come and what? You need to in the office. Sorry about that. Okay, so let's get back to the charts to see what we have missed. We already. So in the weighted pair queuing, what is going to happen? What is going to happen is that this one will be the WI. So notice, the larger the weight getting, what does that determine? If this one is larger, if this one is high, what will happen to this one will become what? Smaller. With the finishing tag will become what? Smaller, which means what? The pair queuing scheduler will what? Serve them ahead of the others. Now, if the question gives you the weighted in fractions, normalize it. So, for example, if he tell you that the weights are what? 1/4, you can make the weights what? 1, and what? 2. You follow me on that? Everything is relative, or not? Or you can keep it a fraction. I mean, it doesn't matter, really, it doesn't matter. Clear? Okay. Okay, as we already talked about this, already talked about the round number, already talked here. This is an example, by the way, of this is the same weight, 4 queues sharing what? 4 bit bandwidth. So we have 4 queues sharing the same, sharing 4 bits of, 4 bits per second of bandwidth. Can you zoom in, please, a little bit? Okay, so now what do I have here? In the first flow, I have a packet with what size? Then what? 3. Then C1, in C flow, I have what? 2 packets. Each one is of what? 1. The D, I have 2 packets. One of them are of size 1, and the other one is of size, and it's the same weight. This, the first example, is the same weight. So what does he do? Can you zoom back? What? No, zoom in. Yeah. Okay, so what is he doing? In round 1, what is he taking? B1, B1, C1, and what? D1. Did you get this or not? No. Cannot hear you. Okay. Now, what is the bandwidth here? 4 bits, which means each one will get what? 1 bit per second. This one is how many units? 1 unit be done. You follow me or not? This one will what? Exit. The C1 will depart here, and this D1 will. Are you following me or not? Yes or no? Okay. Why D1 will depart also here? So we say what? C, both of them departed during what? Round 1. Did you get this or not? This is round 1. What happened? This one is departed. What happened? A2 arrived in here at 4. Clear? And here he wasn't there. A2 arrived at 4. So what? C3 arrived, and his length is what? Is 2. So now, the second half in the second round. This is the first round. A1, B1, C2. Did you get this or not? Why is it C2? Why is it C2? One is finished. C2. Is C3 being served? No, C3 is not being served because the packet ahead of it is still in serve. So A1, B1, C2, D2. This is all round. By the way, did the slope change? The slope did not change. It's still all the flows are what? Are active. Who departed? C2 departed. Because it's also what? 1 bit. Clear? Okay. Next round. Here. No more came. No more came. Remember, this one and this one has already what? Departed. So is this one? D1. Around. What do I have? In round 3, A1, B1, round 3, A1, B1, C3, D2. Yeah? Why? This one started service because this one exited. Yes? Here. Who's exiting? Exiting. B1 is exiting. Did you get this or not? Yeah. Who is exiting? D2 is exiting. Now, around the 3, it's still 1/4. The slope is, okay. Let's see if you can tell me around what? Round 4. What happens in round 4? Now, these have, all of these shaded have what? Exited. Who is served? Is A1 done or not yet? Not yet. So A1, B. Yes? How about C? Is he done or not yet? Not yet. So he gets service. C3. The round. Look at the round. By the way, D gets anything or nothing? Nothing, because he is idle. Where is the round? This is the round. Is that the same as this round or is shorter? Why? Because each more share. Are you following me or not? Yes or no? Okay, who's departing here? Round 4. Who's departing? A1 is departing. Yes? And what? C3 is departing. This or not? Yes or no? Now, tell me, who is getting service in round 5? A2. The round is just what? One flow. Did you get this or not? And then what? The next round, so A2, until he what? He departs. Did you get this or not? Around is when what? When each active flow get what? The same. Did you get this or not? By the way, when I say 5 and 6 here, both of them are A2. Scheduler remain at what? Remain at A2. Remain servicing A2. But he is not in what? In one round. He is going to finish in what? In 2 rounds, because the A2 is what? It's getting 2. Did you get this or not? Yeah.
Is only 2.
Say that again?
The length of A2 is only 2 and bits per second. So one round should finish A2, right? Because there's only one flow is active.
And here you are not. That in reality you are getting an infinitesimal amount of what? An infinitesimal amount from each flow. Are you following or not? Infinitesimal amount of traffic. So you are getting during this round what? Only A2 is what? Is serving. So he is amount of what? Small amount of the bandwidth in there during that time. And then what? Because the other one is what? Idle. So this schedule is going. See, the other one, he doesn't know that the other rounds are what? Are idle. So he, are you following me or not? So he goes, take infinitesimal amount of data. Then what? Nothing there. He goes back again and take the other one. No. Okay, good. Clear? Now, what is in the weighted fair queuing? What will be the order? C1 was the one who exited. Where is the C1? C1 was exited first. Followed by what? D1, followed by what? C2, followed B1, followed by what? Sorry, this is B1 is, are you following or not? When I write it like this, B1 means what? This is the entire pack. It's B1 is 3 units. B1 is 3 units. Then what? D2, A1, whole package, and so on. So this is what? This is C1, D1, C2. This whole thing is what? This is what? D2. This one is what? A4, A1, and so on. So clear? Okay. And then the other example, you can read it at home. The other example, it's are what? 3, 2, 2, 1. What does that mean? When I say 3, 2, 2, 1, it means what? What? In every round, this one will get what? 3 infinitesimal service. Come 2 in here, and what? 2 in here. Clear? The capacity. Can you zoom back, please, a little bit? Okay. Now, let's see if you can help me here. Okay, so what do I have? The same scenario, but this one is what? 3 units, 2, 2, 2, 1. Yes, I have here round 1. Tell me round 1. He's from who? A1. Yes? He gets 1 unit from who? B1. The capacity is what? The capacity is what? And you see, this is round 1. A1, 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 B1. Then what? B1, he gets what? 2 shares, 3 shares, 2 shares. Did you get this or not? This whole thing, we call it a what? Round number 1. Did you understand what I said? It's round number 1. Now, during that, C1, where is C1? C2 also departs. It's also length 1, and he is getting what? Two services. Yes? And who else departs? D1 departs. Did you get this or not? All of this is in which round? Round number 1. Did you get this or not? Okay, then what? Round 2. What do I have in round 2? A1. A1. Oh, A1 has 4 units. Units already what? Served. So it's what? A1. Then he takes what? 2 units from who? A2. Where is A2? I don't see A2. Oh, A2. A2 just right. Clear? So he take what? 2 units from A2. Then B1. B1 unit. He already served how many units? 2 units. But B1 is how many units? 3 units. So, and then what? C3. C3. C3 is how long? 2. So these are the 2 units. Yes? And then what? D2. Was there D2 here? No, there was no D2. The D2 is also what? Why is D2 2 units? 1 second. No, sorry, I'm sorry. This is the third round. I'm sorry, this is the third round. Yes? So this is what? D2. Now, who is going to depart here? 3. Yes? Who's left? Are we done with A2? Yeah, A2 is done. So in the last round, you have only one thing left. Is from what? D2. Did you get this or not? This is what? This one here is a little bit confusing. This one is what? Round? Round 3 is a very short round. Clear? And then the order, of course, is what? Who exited first? Who exited first? C1 exited first, followed by what? C2, followed by what? D, followed by what? A1, followed by what? A2, followed by what? C3, and followed by D2. Clear? Clear? This one took so long. Are you following me or not? To do it again, this is based on what? This is based on the weighted pair queuing, back to our example that we started earlier. Not this example, the one that I just showed you. Example that we started all the queues earlier. I want you to see something here. Do you remember this number? Or is it the same 1.3? It's the same 1.3 in here. Same 1.3. You can read this one at home yourself and figure out all of these. 0, 0 means this packet when he arrived, he did not wait, it away, and so on and so forth. When you average it, you get 1.3. This is a summary. Guess which one is different? Guess which one is different? This is the total time, sorry. This is the delay comparison. Delay comparison means what? E of t plus W, total time. Guess which one is different? The GPS, because it's not implementable. Are you following? Implementable. Clear? Clear? Okay, the rest are all the same values. This example, I just clear so far? Yes or no? Now, if you do have questions, you need to see me in the office. I lost. I'm sorry. Huh? Oh, you already fine? It's good. When you throw numbers at me, it came in here, packet came in here, packet came in here. I have a hard time following the numbers. You need to show. Did you get my point or not? Okay. Now, and how many of you attended yesterday's session, discussion session? Did you give different weights? Did you get it? I mean, did you understand it? Okay, good, good. Let's continue our discussion from the big picture. I need you to understand one thing, is that fair queuing, when we are talking about fair queuing, does not eliminate what? It's not, fair queuing is not a mechanism to eliminate congestion. Managing the what? Congestion by what? By scheduling the services based on what? Based on the one that has the smallest finishing tag. Clear? By the way, if it gets congested, weighted fair queuing, the drop policy, he will, listen to this, he will drop the packet with the largest number. With the largest finishing number is the what? Is the one that will get what? A drop. Are you following? They dropped earlier. So that's the big picture. To combat congestion with both end-to-end congestion like TCP, and we also need what? We need some kind of a support from the routers. Discuss it shortly. the end-to-end congestion control, the end host has to adapt, reduce the rate when he feels that congestion has occurred. And the router congestion control, it's needed to protect and isolate Isolate the flow. You do understand that in fair queuing or fair queuing, create a flow, you are for every flow. So that if one user is abusing by sending too many packets, user will be penalized. Why? Because his buffer will begin to pile. Understand that or not? And the others are are normal operation. Keep that in mind. Now, buffer management, how we manage the buffers, and in it, I will also introduce you to another algorithm, which is called the random early drop or random early detection. Sometimes they call it random early detection. But let's understand how you are going to share those packets. They are sharing the buffer space. Strategies of sharing buffer space. The first one is buffer partitioning. What do I have? Physical buffer, but I'm going to partition it into into n pieces, each for one flow. So they are sharing the same physical buffer, but I partition it into into separate places. And the other type is they are sharing buffer, which means there is no partitioning here. Clear? As I will show in just a second. This is more efficient use of the. Why is it more efficient use of the space? Can you tell me this one? Why is it more efficient use of the space? If other flows are they could the flows that are active can share the space. Sorry, can use the space. Whereas if a flow is empty, that piece of the buffer that you allocated to them will go will clear? Okay. So shared buffer, more efficient use of the space, but may lead to starvation. Stream has a burst. What does that mean? If one of the flows have a long burst, suddenly are sharing the same buffer, other flows might starve. Why? Because they don't. The router does not have a space to hold their packets. Clear? So especially if it has a long burst. Our mixed strategies also are sometimes used. Part of the buffer is partitioned, and part of the buffer is a shared pool. Okay, let's look at the partitioned memory first of all and see if you can follow the analysis. So we have a switch. This is a switch. The packets are coming into. By the way, we will discuss what goes in detail shortly. The packets are arriving into the switch. Clear? This is a buffer. The buffer is the partition queues into any queues. Clear? For each one of these for this input. Now, this is the queue. I'm going to model the queue. Q1, for example, concentrate on Q1 in discrete time. And let's assume, just for simplicity, the packets are all of the same length. Now, in reality, are the packets of the same length? No, but this just to make the model. Let's assume it's of fixed length, and the length is K. Clear? Okay, so let's see if you can help. Here we have time slotted. Everything is coming in time slotted. There is either a packet or no packet. Either a packet or no packet. Which means what type of a model is this? That's a Bernoulli model. Either there is a packet or Clear? The probability that there is a packet is P. The probability that there is no packet is minus P. So now, let's see if you can help me. What is the probability that an arrival J on input J, and it is destined to Output? Why? We are interested in queue number 1. Are you following me or not? We are interested in this part of the memory. Is it possible that here we do this output? Yes or no? You are losing me here. Are you losing me? Yeah, you are losing me here. How many queues do we have? Any queues. How many inputs? Possible that this one and this one are both the packets in here and in here are going to here? Oh no? Which means what? It means I'm trying to say, what is the probability that an arrived J is destined to output 1. What is it? It's P over. What is the assumption here that I made? Can you tell me what is the assumption when I say P over N? What is the assumption? Is that the probability there is a packet in the time slot is Is P. What is the next assumption is I assumed that all of these packets are equally likely to be destined to these queues. Are you following on that? How many Qs do we have? What is the probability? 1 Q. Q number 1 is what? Is 1 over n. Clear? The probability of I packets are headed to Q1. What is the probability that there are I packets headed to what? Q. What is it? It's n choose what? I is the number of inputs. N choose I times what? The probability that it's destined to Q1, P over I times what? 1 minus P over n raised to the power what? N minus I. Yes or no? Okay. Let's see if you can understand the analysis here. Let Qn be the number of packets in the buffer, in this buffer, in the queue. Let Q of packets in the buffer at the end of slot n. At the end of this number n. Yes? What will be the number of packets in the buffer at the end of slot n plus 1? The end of slot number 1, what would be the number of packets? Let's see if you can help me here. What is the maximum of this plus this? Let's understand what is this. What is Qn minus 1? Qn minus 1. Qn is the number of packets in the what? In the queue at end of slot number what? I subtracted 1. You didn't get it. Served. 1 is served. You are not concentrating. Concentrate. Concentrate. We need to look at the overall picture so that you are. First of all, what is Vn plus 1? What is V1? Vn plus 1 is the number of arrivals to output what? I in a slot n plus 1. Which means what? During this slot, let's assume this is slot number what? Slot. And this one is a slot number what? N plus 1. Okay. Slot number n, how many packets were there? Q packets. Packets. Are you following me on that? Now, remember, this one will serve what? 1 packet at a time. This, you see the arrow? What is the number of packets in this queue as a slot? What will it be? Listen to me. If there is no packet in here destined to here, in any one of them, what will be in here? It will be Qn minus 1. Why? 1 is already served. Now, however, if there are packets in here that is headed to this, you need to add it. Did you get this or not? What does this mean? Just this one. The max Qn minus 1, comma what? 0. Is it possible that at the end, is it possible that the queue is empty at the end of excuse me, at the end of slot n? Clear? So is the what? It's the maximum of these two. By the way, if this one is, see, this one cannot be lower than the 0. Do you agree? Okay. The maximum you can get is what? I mean, it cannot be negative. Clear? Okay. What is this? That's the arrival. Yes or no? Okay. Why did I say K, comma K? Why? Remember, K is the what? Is the buffer. You follow me or not? There is no more than what? K units. Do you understand the minimum? Okay, so it's the minimum of what? The maximum of Kn minus 1, comma 0, Vn plus 1, comma what? K. And this one, again, is the what? Where V is the number of arrivals to output I in a slot what? N plus 1. Which means that Vn plus 1 equal to what? I is what? AI. AI is this. Clear? Clear? Okay. Now, each buffer, what does it look like? Each of these buffer, what does it look like? The service time is what? Determinate. Yes? One server. A capacity. Are you following or not? And this one is what? Bueno. Are you following or not? The arrival nominal fashion. Did you get my point or not? Yes or no? Okay, good. Let's look at the shared memory. Let's look at the shared memory. In a shared memory, this is the whole thing. They are sharing. You are not going to partition it in what? Into multiple queues. Let's see what happens. Same ideas here. The input, yes? The model buffer occupancy in discrete time, big the fixed packet length. Okay, the probability of arrivals, what am I saying in here? That's.
Professor, we have a 5-minute warning.
Thank you. What is the probability that, what is the probability that there is a what? There is a packet here. See, if there are no plot, what does it mean? You are not going to use any space in the memory. Do you agree? What is the probability that is what? Is n, choose I, times what? P, not P over n. Not P over n. Look at the previous one. What was it? Why? Because we were only interested, in the previous case, we were only interested in the what? That are headed to what? Q number 1. In here, it's a shared memory. Are you following us? So we are only interested in it or what? It's no packet. So it's what? N choose I, P to the I times what? E to the n minus 1. Clear? Now, let's see if you can help me the modeling stuff. The buffer occupancy. Be the number of packets in the buffer. Which buffer? Which buffer? The whole thing. The whole thing. At the end of a slot n. What is the Q equal to? Let's see if you can tell me what is the Qn plus 1 equal to. Is the minimum of the maximum Qn minus what? Dn plus 1. Why is it Dn? Why it is Dn plus 1? Why it is not minus 1? Dn plus 1 is the number of the in slot number what? N plus 1. Are you following? There could be what? There could be multiple departures. And they're looking at what? 1 Q. And here we are looking at the entire buffer. Vn plus 1 is the what? Is to the shared buffer. In slot N1, N plus 1. Did you get this or not? 0 means what? If the buffer is empty. Okay, what is this NK? Comparing this with the previous one. The previous one, how many partitions? N partitions. Each one, what? In here, am I partitioning it? Then what is the size? It's the same memory. So it's what? N times. Clear? Okay. The number of what? The number of departures depends on the packets in the queue. And we are interested in the statistics of each of these output queues. So we use a what? A vector Qn. This is a vector Qn. It's what? Q2n all the way to what? Qn n. What does that mean? Can you tell me what does it mean? Outlets in here, how many of them are going here? How many of them are coming here? They are sharing the same buffer, but their destination is what? Is different. Did you get this or not? Okay, so we have a Qn. What is this? This is the average number of packets in the buffer. Is equal to what? N, comma, Q to N in a vector type. Now, what is Qn plus 1? This is the number of what? Number of packets, end of time slot N. Is the maximum of what? Q1N, comma, 0, plus what? A1, N plus 1, comma, maximum of this or here. Yes or no? Can you zoom in, please, a little bit? Thank you. I want you to understand this. What N means. This is the number of packets in the buffer that are headed to which output? Why is it minus 1? 1 is following me or not? Yes? What is this? This is what? This is the number of what? The number of the slot N plus 1 arriving that are headed to which? That are destined to which output? This one. You need to add it to it. And then what? With what? With the second one, with the third one, with the fourth one. Are you following or not? And you need to take the what? Each one of them. Did you get this or not? To get this. And then, subject to what constraint? Subject to constraint of QK, N plus 1 at the end of slot number N plus 1, it has to be what? Less than K, because you cannot exceed the capacity of the buffer. Clear?
Time.
Okay, we'll continue this next time. Clear? Okay. Before I let you go, everybody have a wonderful Valentine's Day tomorrow. I don't know what that means. But minutes, get your gifts, whatever, and then what? Execute yourself. You tell them what I need to study for. But make sure to tell them that after you get the gift, not before you get the gift. Before you get them, get the gift.
This concludes E550. It's February 13, 2014.